What is going on, guys? Welcome to this finance tutorial. In today's video, we're going to talk about web scraping. Now, one of the first videos on my channel here was the stock visualization tutorial using candlestick charts. And what we did there was basically using the Pandas data reader in order to get some financial data from the Yahoo Finance API. So we passed a ticker like AAPL or FB or TSLA for the respective company. And then we got some data, processed this data, restructured it, and then in the end, we visualized it with MPL Finance. But one thing that we couldn't do with that, and we still cannot do with that, is getting some S&P 500 data, or actually getting the data of any index. So we cannot get a Dow Jones Industrial Index data. You cannot get a Nasdaq Index data. You can also not get data for foreign indices. Because Yahoo Finance API, this is the way we did it. DF equals web data reader, Apple, Yahoo, start, end. So we specified the ticker, we specified the API, we specified the start, and we specified the end date. Now, what we cannot do here is we cannot just visualize the S&P 500 data. Now, we can maybe somehow find ETFs that represent it, but you cannot get the companies listed on the S&P 500. You cannot pass S&P 500 as a ticker symbol. But you may have reasons to want to do that. So maybe you want to know which companies are listed on the S&P 500. Maybe you want to calculate the S&P 500 index. And of course, you want to do this in your script. So you don't want to just look it up for yourself, but you want to have this data in your script. So what you have to do is you cannot use the Yahoo Finance API, but you have to find another source. And of course, you can look for some CSV files or something. But those have to be up to date, and it's hard to look for them. So what we can do here is we can use web scraping to get them from pages like Wikipedia. So what we can do here is we can go ahead and type list of S&P 500 companies. And here we have a list of the companies. I don't know if this list is up to date, but I think it should be kind of up to date. So here we have all the ticker symbols that we can use then for accessing each of those companies individually via the Yahoo Finance API. So in this video, we're going to learn how to do that. We're going to use web scraping in order to get this data into our Python script. So let us get right into it. Now, before we get into coding, what we need to do is we need to figure out the structure of this website. So what web scraping does is it takes the HTML code of a website and extracts the information that we need. So we need to know how this website is structured and what the HTML code looks like. So what we do is we right-click somewhere onto the table here and click on Inspect Element or anything similar in other browsers. I'm using Firefox here. And then you can use this tool here to basically click on what you're interested in. And we're interested in this little box here, or in these little boxes here. And what we can see here is that we have a table, basically an HTML table here, which is the whole thing basically. And then in this table, we have a head and a body. And in this body, we have table rows. And all these table rows are essentially just obviously the rows of the table. And in each table row, we have table data, which is basically just a column of this row. So we are interested in the table data, the first table data element of each row, because that's the symbol. We're not interested in the other columns here. We're only interested in the ticker symbol because that is what we need for the Yahoo Finance API or for other services. So this is what we basically need. We need to extract the table with the class WikiTable sortable. We need to take the first table of this page here that has this name, because of course down here we have, we need to scroll a little bit here, but down here we have another table which we're not interested in. So we are just going to look for the first table, and from this table we're going to take all the table rows, and of those we're going to take the first table data element, so the first cell basically. This is what we're going to do, and now we get into the Python code. So for this script, we're going to need the beautiful soup library. So what we're going to do is we're going to run cmd, and we're going to activate the conda environment if you have one, and then use pip to install beautiful soup 4. This is the web scraping library that we're going to use. It has a little bit, its name is a little bit odd, but we import it as bs4, not as beautiful soup 4. And then we give it an alias of bs. And what we also need to do is we need to import the requests module, which is part of the core Python stack, so we don't need to install anything for that. And the request module is what we're going to use in order to get the HTML data from the website. So what we're going to do is we're going to send an HTTP request to the website. We're going to get the HTML code as a response. And this HTML code is then going to be fed into a soup object. So we're going to use Beautiful Soup to create a so-called soup object. And this soup object is going to scrape through the HTML code and it offers us a lot of methods to do that in order to filter out the data that we're interested in. So first thing is we're going to say HTML equals requests.get. And now we need to pass the link here, the S&P 500 link. So we copy it and enter it here as a string. We pass it as a string. And then we can also go ahead and say print html.text, because HTML itself is just a response object. If you want to see the HTML code, you need to say .text. And here you can see we now have the full HTML code in our list here, in our script here, sorry. So actually, if you wanted to, you could use string functions to filter out the data yourself, but we can use a soup object to optimize this process to make it a lot easier. So we're going to say soup equals bs.beautifulsoup, and we're going to pass html.text. So we now have a soup object which is based on the HTML data that we provided. And now we're going to define what we're looking for. So first of all, we want to have the first table. So we're going to say first table or just table equals soup.find, and we want to find a table object or table element with the attribute, and now we're going to pass a dictionary for that. The attribute class shall be equal to wiki table sortable. Now, depending on the time you're watching this, this might have changed. I don't think so, because this works for 2 years now, at least 2 years now, but you can check out the Wikipedia source code, actually just the HTML code, to figure out if this is still the case. However, this find function here gives us only the first table element. So we're not using find all or find multiple of those. We're just getting the first occurrence of this table or of a table with the class wikitable sortable. So this is the first table because our table is, the table we're interested in is the first table on this website here, or at least the first wiki table sortable. I don't know, maybe Wikipedia structures its page so that some of these elements here are tables. I don't know. But this is just a table, and now what we want to do is we want to get all the rows, every single row of this particular table, and then from this row we want to get the first column, the first cell. So what we say is we say, first of all, we need to define a ticker list where we're going to store all the tickers. So we're going to say tickers equals empty list. Then we're going to say rows equals table, and now we're going to use find all, not just find. Find all. We want to find all the elements that are table rows, so TR. With one exception, because if you look at the website here, if you look at the table here, we're not interested in this head here. So we're not interested in symbol, security, and so on. We're interested only in all of those rows here. So not the first one. So basically, we're just excluding it by saying skip the first index. We're starting at index 1 up until the end. So we're using index slicing here to get all the rows. So this returns a collection or a soup collection, you could say, of all the row elements. And we, of course, can iterate over it. So we can say for every row in rows, what we want to do is we want to say ticker. The ticker that we're seeing in this iteration is just the row. Find all the table data of this row and pick the first one. And from this one, the text, the HTML text. Then we say tickers dot append ticker. So again, what we're doing is we're getting the first table, all the rows, iterating over the rows, and for each row, we get all the table data, pick the first one, which is index 0, and get the text of it, which will be the ticker symbol, and then we append this ticker symbol to the tickers list. So this is actually it. We can now go ahead and print the tickers, and you'll see that we will have all the S&P 500 tickers in the list here. So you can see the only problem here is that we have a \n. So what we can do is we can actually not append the whole ticker, but skip or remove the last two characters. So basically up until -1 should do it. Cutting off the last two characters. As you can see, it works. So we have all these ticker symbols here. And now what we can do is, of course, we can export them to a CSV file. We can use them directly to iterate over it. So I'm not going to complete all the whole Candlestick project again, but let's say we have a data reader. Now what we would do, we would say for each ticker in tickers, we could say, I don't know, what was it? Web equals, not web equals, df equals something like data reader or some, web.data reader was it, I think. And we could say ticker and then Yahoo and so on. And then once this is done, we could take this data frame and save it. So you could save the whole S&P 500 companies and all its data into a CSV file, so you don't have to access it. You can then also, of course, compute the index or basically calculate the index value. However, now you have it, and if you don't want to get it downloaded every time you run it, what you have to do is you have to just say with open. For this, we're going to need pickle though. So we're going to say pickle with open, I don't know, SNP. I'm going to call it SNP so I don't have to use the and sign. S&P 500 dot pickle as file or sf, and then we're going to say pickle dot dump, and we're going to dump the file into this file. We're going to dump the tickers, and now we should get a new file here. No, we didn't get a new file. No such file. Oh, sorry. Need to open it in write binary. Now it works. And of course, we can now, I think at least we should be able to do this. We can now just say import pickle, and then we can say with open S&P 500.pickle read binary sf. It was something like pickle load f. Yes, this is data, or actually we can call it tickers. And then we can say print tickers. I think this should work. There you go. It works. As you can see, this is how you get all the data from Wikipedia, how you web scrape it, save it, and then load it again into your script. So that's it for today's video. I hope you enjoyed it and I hope you learned something. If so, let me know by hitting the like button and leaving a comment in the comment section down below. Also, if you're interested in more finance or web scraping tutorials, also let me know in the comment section, because then I can react to it and make more videos to these topics. And if you haven't done it yet, subscribe to this channel to see more future videos for free. Other than that, thank you very much for watching and see you in the next video. Bye.